two projects. In this video, we are going to explain the project, a stock price prediction model based on investor sentiment and optimized deep learning. Introduction. The primary goal of this project is to enhance the accuracy of stock price predictions in China's ever-changing stock market. The project holds significant importance in the financial world. By improving the quality of stock price predictions, it directly contributes to reducing the risks associated with investment. Both individual investors and businesses stand to benefit. For individual investors, more accurate predictions mean better decision making, potentially leading to higher returns and lower losses. For enterprises, this project aids in optimizing their financial strategies, enabling them to make informed choices in the volatile Chinese stock market. In the broader context, such improvements promote stability and growth in the financial market. And traditional methods like ARIMA, and GARCH models have served as historical tools for stock price prediction. However, their assumptions often fail to capture the intricate and unpredictable nature of today's stock markets. These methods rely on linear and structured data, which do not adequately represent the complexities of real-world financial data. And to overcome the shortcomings of traditional methods, this project turns to advanced deep learning techniques. Deep learning models are capable of processing vast amounts of data and uncovering intricate patterns that traditional models might miss. By integrating investor sentiment and other relevant variables into the deep learning model, it becomes more adaptable and accurate, potentially offering better insights into the volatile Chinese stock market. Objective of the project. So, as I mentioned earlier, the project's objective is to create an advanced stock price prediction model that leverages a combination of diverse data sources, sentiment analysis, swarm intelligence algorithms, and deep learning techniques. The primary goal is to enhance the precision of stock price forecasts, thereby empowering investors to make safer choices and realize greater profits in the financial market. This project focuses on extracting sentiment from discussions on the East Money Forum. Additionally, it incorporates the Sparrow search algorithm to fine-tune hyperparameters in long and short-term memory networks, aiming to optimize the predictive capabilities. And the project seeks to demonstrate that the MSSSA LSTM, that is multi-source Sparrow search algorithm with LSTM model, outperforms other existing models and exhibits a high level of versatility in different scenarios. It also aims to assess the model's suitability for short-term predictions within the context of China's dynamic and often volatile financial market. Software and hardware requirements needed are software requirements: Anaconda, primary language of Python, front-end framework Flask, back-end framework Jupyter Notebook, database SQLite 3. Front-end technologies used are HTML, CSS, JavaScript, and Bootstrap. Hardware requirements needed are operating system of Windows, processor of i5 and above, RAM of 8GB and above, hard disk of 25GB and above. Now we'll discuss the working modules of Flow of Work. The first step is importing required packages. In this step, we will import essential libraries such as NumPy and Pandas for data manipulation and analysis, sklearn for machine learning and data pre-processing, Matplotlib and Seaborn for data visualization, and TensorFlow Keras for deep learning. The second step is exploring the dataset. In this step, we import required datasets, employ exploratory data analysis and feature correlation analysis to better understand the datasets. These techniques help reveal data distributions, outliers, and relationships between variables, aiding in subsequent data processing and model building. So the first dataset imported is stock tweets. This dataset consists of tweets related to stock market activities. It includes text data and sentiments. The second one is single stock data. This dataset provides detailed information about a particular stock from a single company. It encompasses a range of financial metrics such as stock price, trading volume, historical performance, and other relevant stock-specific data. And the next one is all stock data, that is multi-source data. This dataset is a compilation of stock-related information from multiple sources. It includes data on various stocks such as their historical performance, trading statistics, and other financial indicators aggregated from different outlets. The third step is visualization using Seaborn and Matplotlib. In this step, we employ Seaborn and Matplotlib to create visual charts and graphs, facilitating a better understanding of dataset characteristics. The next step is data processing. In this phase, we are getting the tweets ready for sentiment analysis. We clean them up by removing punctuation, HTML, URLs, and emojis to make them easier for the machine learning and deep learning models to understand. After that, we use a tool called the Keras tokenizer to convert the words in the tweets into numbers so the machine learning and deep learning models can work with them more easily. This step helps with sentiment analysis. The next step is train and test split. In this step, we segregate the dataset into training and testing subsets. The training subset is used for model learning while the testing subset evaluates the model's performance on new data. The next step is training and building the model. So, in this step, various machine learning and deep learning models are developed and trained using the prepared dataset. The models are created for specific tasks such as sentiment analysis or stock price prediction. And in the next step, that is extension phase, ensemble models are created by combining predictions from multiple models for improved accuracy. So we employ the preprocessed dataset to train machine learning and deep learning models. These models learn data patterns and relationships. Subsequently, we evaluate model performance on a separate test dataset, employing metrics like accuracy, precision, recall, F-score for sentiment analysis, and MSE, RMSE, R-square for stock price prediction. This evaluation step helps ensure the models are accurate and reliable for real-world use. And additionally, a user-friendly Flask-based frontend with authentication was developed. The next step is Flask framework with SQLite for sign-up and sign-in. In this step, we integrate user registration and login functionalities into the Flask framework. Users can sign up by providing their information, and subsequently they can securely log in using their credentials. This enhances system security and allows for personalized user experiences. So after signing in, users interact with the system by providing a symbol for a stock. This symbol serves as input for further analysis. So the provided ticker symbol is preprocessed and data related to that stock is collected through web scraping from sources like Yahoo Finance. The preprocessed input is fed into the trained models and the models make predictions, and the results are presented to the user through the front-end interface. Now we'll discuss about the algorithms used. The first one is MLP, that is multi-layer perceptron. MLP is a versatile neural network architecture with multiple interconnected layers, often used for tasks involving structured data. In this project, MLP have been chosen for its adaptability and ability to learn complex patterns from diverse data sources, making it suitable for stock price prediction. The next one is CNN, that is Convolutional Neural Network. So CNN is a deep learning model designed for image analysis but can be applied to structured data by treating it as a grid-like structure. It excels at feature extraction, which is relevant to the project for capturing patterns in stock data. The next algorithm used is LSTM, that is long short-term memory. So LSTM is a type of recurrent neural network specifically designed for sequential data analysis. It is known for its ability to capture dependencies over time, making it a strong choice for modeling stock price fluctuations. The next one is MS-LSTM. So MS-LSTM involves integrating data from various sources for comprehensive analysis. This extension of LSTM allows the project to leverage a broad range of information for stock price prediction. The next one is MS-SSA-LSTM. So this model extends LSTM by incorporating the Sparrow search algorithm for hyperparameter optimization. By doing so, it aims to provide a more accurate and robust approach to stock price prediction, addressing parameter settings objectively. So this is the horizontal bar graph comparing accuracies of different algorithms. In this graph on x-axis I have accuracy scores and on y-axis I have algorithm names. So accuracy measures the overall correctness of predictions, showing the percentage of correctly classified instances. This is precision comparison graph. In this graph on x-axis I have precision scores and on y-axis I have algorithm names. So precision measures the accuracy of positive predictions, indicating how many predicted positives were actually correct. This is recall comparison graph. In this graph on x-axis I have recall scores and on y-axis I have algorithm names. So recall measures the ability to identify all relevant instances, showing how many actual positives were correctly predicted. And this is F-score comparison graph. In this graph on x-axis I have F-scores and on y-axis I have algorithm names. So F-score combines precision and recall into a single metric, balancing accuracy and completeness in predictions. So these are the comparison graphs for stock sentiment classifications. And this is horizontal bar graph comparing R-squares of different algorithms. So in this graph on x-axis I have R-square and on y-axis I have algorithm names. So R-square is a statistical measure used to determine the proportion of variance in a dependent variable that can be predicted. This is MSE comparison graph. In this graph on x-axis I have MSE scores and on y-axis I have algorithm names. So MSE is the average of the squares of the errors. This is RMSE comparison graph. In this graph on x-axis I have RMSE scores and on y-axis I have algorithm names. So RMSE measures the average difference between values predicted by a model and the actual values. And this is MAE comparison graph. In this graph on x-axis I have MAE scores and on y-axis I have algorithm names. So MAE is the average variance between the significant values in the dataset and the projected values in the same dataset. So these are the comparison graphs for stock price predictions. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So this is the data folder in which I have required files, required datasets on which we will train the machine learning and deep learning models. This is static folder in which I have files related to CSS, JavaScript and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML pages. And these are model files which contain algorithm information. These files will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter Notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. And this is signup.db file. This file is the database file used to store user information. Now copy the path of the code folder from the address bar of the file explorer. I'm copying it. Open Anaconda prompt. Use the command cd followed by a space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, the Flask framework will host the application locally at the default address localhost and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So here we can see a sign up link, click on it. So if we are new users, we have to register first. Fill in all these details and click on login button to register. And if we already have an account, we can directly log in by clicking on this link. So as I already have an account, I'm clicking on this link. So here we have to provide our credentials, username and password. And now click on login button. So here we have to provide a ticker symbol as input. So I'm giving Amazon ticker symbol as input. Now click on go. So it will take some time to load. So here we can see today's Amazon stock data. Now scroll down. So this line graph depicts the fluctuations in stock prices over a span of 2 years. And this graph shows how well the ARIMA model predicts values. The red line is what actually happened and the blue line is what the model predicted. The two lines are very close, which means the model did a good job predicting. And this graph compares the actual data shown in red with the predicted data in blue using the combination of LSTM GRU model. There is a noticeable difference between the two lines, suggesting that the model's predictions vary considerably from the real values. And this graph illustrates the accuracy of the extension voting regressor model. In the graph, red line represents the actual values and the blue line represents the predicted values. There is a significant difference between the two lines, indicating that the model's predictions differ substantially from the actual data. And here we can see the closing price of the stock predicted by the models. So this is the closing price predicted by ARIMA. This is the closing price of Amazon predicted by LSTM and GRU model. And this is closing price predicted by voting regressor. And here we can see the RMSE scores of the models. And ARIMA model has secured the least RMSE, which means it is doing well when compared to other two models in this particular project. Conclusion. So the MSSSA LSTM model designed for stock price prediction outperforms other models in terms of accuracy and precision. Its universal applicability makes it a valuable tool for investors. By incorporating a sentiment index, the model's predictive performance is significantly enhanced, underscoring the crucial role of sentiment analysis in forecasting stock prices accurately. And the model optimizes LSTM's hyperparameters using the Sparrow search algorithm, providing an objective explanation of model parameter settings and improving prediction accuracy. The model excels in short-term predictions, particularly in China's highly volatile financial market, offering valuable insights for investors. The integration of multi-source data, sentiment analysis, swarm intelligence algorithms, and deep learning techniques in the MSSSA LSTM model represents a holistic approach to stock price prediction. Its capacity to reduce investment risk and enhance returns underscores its significance in the financial market. And ensemble models exhibit impressive accuracy and precision, further diversifying the toolkit for stock prediction and providing robust alternatives.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.